Hi guys, today I'm going to do a series of videos on the symmetry properties of the unit circle. So this is in 2.2 of your Jack Plus textbook, and I'm going to work through the worked examples and explain them a little bit more clearly. So this is one we did yesterday, but some people are still a bit unsure, so I thought I'd start with this. So we've got two situations here. One is where we've got sine theta and one is where we've got cos of alpha. And what we need to really understand is that these are two separate triangles. So I'm just going to draw two pictures to represent what is shown here. So sine theta of root 3 on 2. So that means we've got a unit circle. It means we've got a triangle and it's in the first quadrant because that's what they're telling us. And now the sine value, so the sine value refers to the y value of the point or the upright length of the triangle. So here's our right angle triangle here, and in our angle is theta. So this has nothing to do with alpha or the cos of alpha. So here we can write root 3 on 2 because that's the length of that yellow line. This is not 4/5, so that's wrong. 4/5 is nothing to do with the angle of theta. So now let's draw what is to do with the angle of theta, of alpha rather. And it's also in the first quadrant, and our angle is alpha, and the cos value, and cos refers to the base length of the triangle. So this cos value here is 4/5. So this length of the triangle horizontally is 4/5, and it has an angle of alpha, whereas the height of this triangle over here is root 3 on 2, and the angle is theta. So it's really important that you can separate the two, and that's where people go wrong a lot of the time. So now let's see what they're asking us to do. They're saying sine of pi plus theta. So this has a theta in it, so we need to identify that this is referring to this. So for the purpose of this, we can ignore the alpha. We're just dealing with this one because it's got theta in it as well. So now I'm going to draw a picture which represents the sine of pi plus theta. So let's do that. So here is pi, takes us over to there. And then we're adding on whatever this angle of theta is. So if we were in degrees and this was 180 degrees, because pi is 180 degrees, it would take us to the straight line still. And then if this was, say, 30 degrees, then you would be going a little further this way till you get to 210. So we would know how to do that. What people struggle with is when it's theta and pi. We just have to see that, well, in here is theta. So this is pi, the straight angle, and we're adding theta. So the whole angle there is pi plus theta all the way to there. So being able to draw that is really essential. So really take time to make sure you understand how I've drawn that. So now I have my right angled triangle here. And what we need to remember is that whenever we draw the right angled triangle, it makes part of the butterfly. So what I mean by that is if we draw our angle in the third quadrant, it looks like that. Second quadrant, fourth quadrant, first quadrant. So see, it's part of a butterfly. So that's how you draw all your triangles. I'm going to take those off now. So look, now let's look back to the circled picture here of the unit circle. And what we see is that this yellow line here, being root 3 on 2, we are moving this triangle around the circle. So what happens is if we were to pick up that triangle and put it here, well, that's where your yellow line would be. It would be at the bottom there. So this length here is still root 3 on 2. So the actual triangle, it originally looked like this. Then we kind of flipped it over or rotated it, if you like, around, and so that it lay down like this way. And now, well, this yellow line is represented here. So if we want to see our physical length there, of our sine pi plus theta, it's still root 3 on 2. But what we need to also consider is whether it's positive or negative. So this is the point here, and this y value, which sine represents the y value of the point, well, that's going to be negative. And you can see that because, well, this would be a negative y value if we're referring to like a Cartesian plane, if this was y and x, and of course y is representing sine and x is representing cos. Well, if that was the case, then the y value would be negative. So I need to put the negative in too. So we have two steps. First of all, find out the length, and second of all, determine whether it's positive or negative. Let's move to the next one. So again, we need to determine which of the original pictures we're going to work with. Are we working with the theta diagram or the alpha diagram? And this is asking us for the cos of negative alpha. So this has nothing to do with theta there. It has everything to do with the cos alpha one there. So I'm going to draw the original picture again, just so we've got it handy. So triangle in the first quadrant, it's a right angle triangle, and the cos value is the x coordinate of this point, or the length at the bottom of this triangle, and that's 4/5. And of course, alpha is the name of the angle there. So that's our original picture, which shows this. We now need to see the cos of negative alpha. Now, people get a little bit confused because negative cos alpha is not the cos of negative alpha. So this means, so this one here means -1 times cos alpha. And we know that cos alpha is 4/5. So that's -1 times 4/5. So that would equal -4/5. So you'd get a negative value there. If we're looking at the cos of negative alpha, this refers to a negative angle. So when we've got the negative with the angle, this is a negative angle. And while that means we actually measure it in the negative direction of the unit circle. So going this way is of course positive, going this way is negative. So what we need to do, we start at 0 and then we go down this way by alpha. So we're putting that triangle into that quadrant there. I'm just going to draw it on a separate unit circle here. So I'm going down to here, and there's alpha, and it's now in the negative direction, so we're going negative alpha there. And well, what we see is really this triangle here, it started off like this. Now all I'm doing is flipping it upside down, so it actually just goes like that. So the alpha here, and what you can see is that in fact the cos value is still in exactly the same spot. So the x value of this point, or this line here, we can say is still a positive value. So the cos is still 4/5. It's not -4/5. So cos of negative alpha is 4/5. And you can see this is quite a good example because it really shows us that, the negative cos alpha is different to the cos of negative alpha. Really important then. All right, let's move down. I think we've got 5 or 6 to do of these. So now we're looking at tan, and this is the tan of theta. So I'm going to cross out the alpha bit because that's irrelevant. It has a theta, this has a theta. So we're using this information here. So let's draw the original, the sine. And it's in the first quadrant, as they tell us. The sine is, of course, the height of the triangle, and we know that that is √3 on 2. And now we need to find the tan of theta, and actually I should put that theta in there. So, well, this is a little bit more tricky. Tan theta equals sine theta over cos theta. And lots of people are going to stuff that up because they're going to say tan theta equals √3 on 2 over 4/5. But remember that whole thing, how alpha has nothing to do with it. We are looking at a theta angle, so alpha has absolutely nothing to do with it, so we can't do that. we need to find our cost value. So let's see how we can do that. So here's cost down here. I might make it green. And then we have one more piece of information here. And remembering that this is a unit circle. So this is 1 unit, the radius is 1 unit. So this means that now we can say to find cos theta, so let's take that triangle out so it's a little clearer. Root 3 on 2, 1, and we're trying to find cos theta here. So we can say that this is Pythagoras, a squared plus b squared equals c squared. We've got c, we've got b, let's find a. So a squared equals c squared minus b squared. A squared, or actually cos squared theta. And the way we write cos theta squared is like this, so with the square in between. C squared, which is 1 squared minus root 3 on 2 squared. So we get cos squared theta equals 1 minus 3/4, and that's cos squared theta equals 1/4. And of course, well, then we've got to square root both sides. So cos theta equals plus or minus half. And this is where you need to decide, is it going to be positive or negative? So in this quadrant, in the first quadrant, because we're just in the first quadrant here, it means that our cost value is positive. And we can see that because, well, the x value of this point would be positive. So we can remove the negative. And now we know this length here is half. So now we can just say, well, tan theta is sine over cos. So root 3 on 2 over cos of half, or cos half, cos equals half, I should say. Tan theta equals root 3 on 2 divided by half, and that equals root 3 on 2 times, keep, change, flip, cancel those. So tan theta equals root 3. So that one was a little bit more involved because we had to find the value of cos before we could find the value of tan. And just to be really sure about that, you must make sure that you do not use the alpha value. So alpha has nothing to do with theta. We are looking at theta here, so we must use the information only for theta. All right, moving on. All right, so now the cos of pi minus theta. So again, it's talking about cos, but we're not using alpha. So this is what's relevant. So again, people will be confused because there's a cos here and a cos here. It doesn't matter. This is theta. Oh, sorry, that's not theta, that's pi. This is theta, so we must use this information. Ignore this. Let's draw the original picture again, or the original unit circle with sine theta. So we can refer to that easily. There's our theta. Our sine is root 3 on 2. Of course, it is the upright length of the triangle, the right-angled triangle more specifically. So let's see, cos of pi minus theta. So I'm going to draw this separately over here. And pi takes us to there. So again, think about it as if it was degrees. It would be 180 minus an angle. If that angle was 20 degrees, then you'd be going to 160. So you'd actually just go to here. So you'd have a little bit, left over on the left hand side. So the same thing, we're going to pi, but then we're going back by theta. So we put here, and that means that this angle in here is theta. And I'm going to make the triangle again. The triangle is part of the butterfly. This, 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 this. So don't get confused with how to draw your triangles. It always forms part of the butterfly wings. So now we're trying to find the cos of pi minus theta. So we're trying to find the horizontal length there, the base length of that right angled triangle. That's what we want. What we've got, well, if you take this triangle and flip it over into the second quadrant, you can see that that yellow line is there. So we still have root 3 on 2. And then, well, here we know this is 1 again, so we can work out this cos. And in the previous example, over here, whoops, That's exactly what we did. So we found out that the cos was half. So in our previous example, our cos was positive half along there. So we can use that information to say, well, I might just pop that in there, half and 1. Now it's over here. The physical length of that triangle is half. But what we see is that if this was a point on the Cartesian plane, just even like an xy, you can see that the x value is negative. So that means your cos value is negative. So we consider the length we've found to be half, but we also must consider whether it's negative or positive, and in this case it's negative. So there we go. Moving on. So now we've got one of the alphas being an alpha angle being used, and again we must look at the angle. That's what's important, not the sign, because it says sine here and sine here. No, that's irrelevant. Don't even look at that. So let's draw that cos alpha again. So there's an alpha angle and 4/5 exists here. And then, well, now we're looking for the sine of pi plus alpha. So let's draw that. So pi takes us to there. And then we're adding on alpha. So alpha is in here. And we know that the physical length of the base of the triangle is 4/5. So I'm just going to make that green then. We don't know what sine is, but we do know that it is 1 unit in the unit circle. So I'm just going to take that triangle out and again use Pythagoras in order to solve for our sine length there, or I'll make it yellow, this yellow bit of the triangle here. So we want to solve for this. We have the green one and we have 1 unit for the unit circle there, so 4/5. And then, well, let's call this C, B and A squared equals C squared minus B squared. So A squared equals 1 squared minus 4/5 squared. So A squared equals 1 minus 16 on 25. So A squared equals 25 over 25 minus 16 on 25. Excuse me, A squared equals 9 on 25. Oops, that should be a 5. And of course, when we square root, we're going to get A equals 3/5 plus or minus. And in a physical triangle, well, the only value you could have would be 3/5. It wouldn't be negative. Let's take a look at our picture though, and we see this length for sine. So yes, it's 3/5. But now we need to decide if it's positive or negative. So again, think about a normal Cartesian plane, x and y axis, and sine refers to the y axis. Your y value here would be negative. So it's going to be negative 3/5. So I guess I'll write it here, equals neg 3/5. All right, I think there might be just one more. Okay, so now we've got the tan of 2 pi minus alpha. So now you should be pretty used to seeing, well, this is an alpha, so we're using this. Ignore this. So I'm going to quickly draw that because we've drawn it many times. Alpha, cos is 4/5. That length there, we'll make it green. And then now we're looking for the tan. Tan, we always should think tan equals sine over cos. And more specifically, tan alpha equals sine alpha over cos alpha. So let's see. Again, we have to draw a second unit circle. And now it's 2 pi, so all the way around to 2 pi. There's 2 pi. And then we're minusing alpha. So we go all the way to here, then minus a little bit to get to alpha, to get to here. So it's going to be like this, and there's going to be an alpha in here. So let's see now if we move that triangle around. I mean, really, we could just flipped it over. This value is still the same, 4/5. It's still positive as well. This is still 1. We need to find the sine value because then we can do sine over cos. And I believe we just did that a second ago. Yes, we did. It's 3/5. So our physical triangle, if we take it out, we have a right angled triangle with 4 fifths, 1 and 3 fifths, like this. So now we can say this length here, this is our sine value of 3 fifths, but because it would be a negative point for the y value, it's going to be negative 3 fifths. And that means tan of 2 pi minus alpha is going to be the sine, which is neg 3 fifths, over the cos 4 fifths. So that's going to be neg 3 fifths divided by 4 fifths, neg 3 fifths times, keep change flip, 5 on 4, cancel, cancel, equals negative 3/4. So tan of 2 pi minus alpha equals negative 3/4. And that is that. And I think that's the end of them there.